Blog Talk Radio.
Welcome to the AME Food Testing Show. Today's topic, the use of Pathatrix technologies in food testing with Melanie Patterson, Life Technologies. Melanie is the food safety consultant for Life Technologies in Europe. She's based in the United Kingdom. Her role is to understand market requirements and apply her microbiology background to identify what solutions Life Technologies can provide to better meet customer testing needs. She works closely with commercial teams, product management, and research and development. She's been with Life Technologies for 5 years. She enjoys frequent customer interaction and attending industry forums and events. Her background includes a bachelor's degree in science in microbiology and 13 years working in the food safety industry. She's worked in a contract laboratory, both at the bench. Melanie is a key account manager for food safety testing solutions. Now, welcome with me to the AME Food Testing Show, Melanie Patterson. Melanie?
Hello, Andy. Thank you for the introduction.
Well, you're an esteemed guest today. Let's begin with our first substantive topic. What is the goal of food testing for human pathogens?
Food safety testing is critical. It's important to ensure that there are no human pathogens in the food that we consume and that we eat on a daily basis. If there is a food pathogen there, it can make you ill, and that can be anything from an upset stomach, which may take you away from work for a few days, up to hospitalization and even death, as we sometimes hear in the news. If you imagine that you're the consumer, you're cooking a meal for your family, you want to know that it's safe to eat. Now imagine if you are the food manufacturer, you're sending your food products out there, you need to know that no one is going to be ill as a consequence of eating that food. So, of course, brand reputation is important as well. So it's a critical step for anyone involved, and that's why you see so many industry-specific regulations in place as well.
Well, Melanie, I try to eat it at least 3 times a day. And you, with your scientific background, which bacterial pathogens cause the most harm to humans?
The ones that are most recognized include Salmonella, Listeria, and there are various E. coli strains as well. And viruses are becoming more important in the industry too, and people are becoming more aware of them. And they affect any food that you eat. And that can be from raw meats through to ready-to-eat food, from bakery through to fresh produce. So it really is critical with all of those pathogens.
Melanie, as you are a manager of food safety testing in one of the world's largest companies, what are some of the methods to detect these pathogens? There
are 3 main types of testing methods, I'd say 3 main categories that most laboratories will be familiar with. The first that I'll mention is traditional. So this is culture, sometimes called agar plates. It's a method that's been around for over 100 years, and it's very well known and very well used by, I'd say, almost every laboratory. But it does have its limitations. So the time to get your results, so to know that Salmonella isn't in that product, can be very lengthy. It can be up to 4 or 5 days. The results, when you look at the plates, are quite subjective, so you need a highly trained staff who are used to looking at the colonies on the plate and know what they're looking for so that they don't miss anything. The traditional method does involve a lot of handling as well, so if there's a laboratory that has a lot of tests to run, they can have a lot of hands-on time, a lot of space required as well. So there are quite a few limitations there. The second method, which again is familiar to most laboratories, is called ELISA. It's where you use an antibody to capture your target organism. And it's used as a rapid alternative to culture. So for Salmonella, it will reduce the testing time down from 4 days to usually 2 days, so it gives you a quicker result. But again, it does have some limitations, sometimes with sensitivity, and people are looking now for more innovative techniques, something more specific and sensitive. And that brings us on to the third category, the third type of method which tends to be used, which is molecular, also known as real-time PCR. It is perhaps the lesser known in the industry of the three, but it is changing rapidly. More and more laboratories are asking for it because it's seen as the most accurate method. Laboratories are becoming more familiar with it and more comfortable with it. It used to have a reputation as being quite difficult to run, needing quite a high skill, specific laboratory equipment, for example, and it's much easier to implement now, much easier to use. And one of the main benefits of it are the sensitivity and the quick time to results. One limitation that people can be a little bit nervous about is inhibitors. So some of the food products that people test may have an inhibitor there which can cause a problem with their testing, but that's where the sample prep comes in. So you'd have an extraction method that goes in between your enrichment and your actual PCR, and the quality of that will help to remove those inhibitors to make sure you maintain that accurate result.
Well, Melanie, that leads us to our next question. In the area of sample preparation, how does the Pathatrix technology address those challenges?
The Pathatrix system is unique. It incorporates antibodies to capture your target organism. And it's a system that's automated. You simply load your samples in and it does everything for you within the space of just 15 minutes. And what it will do is it will use the magnetic beads to capture your target organism. So Salmonella is an example. We have kits for Listeria as well, and many other targets. What it will do by capturing that specific target is it will reduce any false positives that you may get with some rapid methods. And if you have a culture plate after it, then it will clean up that plate. It will make it much easier to read. So you quite often would have other organisms in your food product that you're testing, and it will help to take those away before you go onto your test. It incorporates an online wash step to help remove the inhibitors that I mentioned. So if you then go on to PCR after Pathatrix, you don't need to worry about that and false negatives that may come from that. And that's important to some industries like chocolate, for example. The one really big benefit as well that I must mention is the throughput. So what Pathatrix does is it allows you to pull up to 10 samples together after you've enriched it. So you still have the original sample to go back to, but you're pulling up to 10 samples, which means you have less processing to do on the bench, less handling, and fewer detection methods, fewer detection reactions to run. So it really does make throughput much easier, handling much easier, and it fits in front of any detection system. So, if you're using culture at the moment, you can put it in front of that. It will just fit in between your enrichment and your culture. You can put it before an ELISA test, and you can put it before PCR. So it really is unique in that sense that it's universal, and it requires a very, very low skill set.
Well, Melanie, and you worked in a contract laboratory both at the bench and troubleshooting. Can you explain what is recirculating immunomagnetic separation technology, or RIMS?
Yeah, this is the part which is unique to Pathatrix. So there are other methods out there which incorporate immunomagnetic separation. That's the IMS that you just mentioned. And that's where you have your capture antibody bound to a magnetic bead, and it will capture your target organism, your Salmonella, for example. We have other methods for that too. We offer the Dynabeads, for example. The difference with recirculating immunomagnetic separation is that instead of taking a small volume, 1 ml, for example, and putting it through a series of tubes, what this will do is it works with a much larger sample volume. Here you can take up to 50 mils, and it will recirculate the entire 50 ml of your sample over a capture magnet that will capture your beads. And it will circulate it several times so the entire sample goes through and captures anything that's within the 50 mils. And that's the difference. It's the starting volume that makes a difference to the laboratory running their test. Because ideally, you'd want to test the entire sample that you have, but you just can't do that because otherwise there'd be nothing left to eat. But by taking 50 mil off your sample instead of 1 mil, you're really being much more accurate in your results and your testing and the final results that you're going to provide.
Melanie, how does a high-volume wash, which is what we're talking about, enable the efficient removal of sample matrices and nonspecific microorganisms and PCR inhibitors? We need a little clarity on how that all works.
Okay, so what I've just mentioned before is a capture phase. What you'll do is you'll have the 50 mil of your sample recirculated over your capture beads and a magnet, and if there's any salmonella in there or target organism, it will capture it on that magnet. Once it's done that and gone through the entire process, your sample will be moved away into a certain vessel that's all within the system, and all this is done automatically for you. The system will then move on to a wash buffer that again is preloaded, and it will wash that past your sample which has been captured on the beads, so if salmonella if it's there. And what it will do is it will wash away everything that isn't stuck to those beads. And because your beads are specific, you're only going to capture what you want. So when you do that wash step, it means that any non-target organisms, any bacteria that may interact with your detection methods will be removed. And it also means any inhibitors that may be in there from your spices or your chocolate, they will be removed too. So you're really getting a very, very clean and pure sample to work with. And that wash step is automated and it goes through several cycles, so it's as robust and easy to use as you can possibly imagine. And at the end of that process, you will have your concentrated sample containing just your target organisms available at the end of a tube, ready for you to move on to your detection method of choice.
That's an excellent framing of the role that Pathatrix system plays. It takes the raw sample, runs it through an automated system, and at the end of that, then the laboratorian can examine further using analytical methods. What are the advantages of Pathatrix as compared to any other alternatives?
There are so many. The first one to say is that it increases your efficiency. It really streamlines your workflow and makes it much leaner. So, as I said, you can reduce the number of detection reactions you need to run by 10, and that applies to any detection method you're using. It's great for market segments, food industries who have challenging samples, like I mentioned, chocolate and spices. And also it's really important where accuracy and sensitivity is critical and key. So if you imagine infant formula, for example, if there's anything in there, they really want to find it. And the larger sample volume that you have with this and the cleaning capabilities really will help those industries out. The larger samples as well, they're also fantastic if you have an outbreak or an emergency situation. So I mentioned before that you could pool samples. In this case, you might have 5 mil of 10 samples to create your 50 mil working volume. What you can do if you want is just have one sample, 50 mils, so you're working with a much larger sample volume. And so if a food manufacturer is in an emergency scenario, then they can really be sure that they're going to screen their samples in the best way possible. And the final point to mention is that it's a technology and a system that can be used by anyone. It's plug and play, the instrument, you just put it on your bench. It has a very small footprint. You don't need an engineer to come in and install it. You only need a couple of hours training for anybody to be able to use it. You know, I use it, other people have used it very, very easily within just a couple of hours. And it also means that you can redo the training in-house. You don't need to bring a specialist in to be able to retrain any new staff that may join the team.
Melanie, as I'm looking at a picture of the unit, and I've also posted one on the website. It looks like there are 5 modules. Is that correct?
That is correct, yes, and they can run independently. So you can have one cartridge, we call them, running at any one time, and that can have, as I mentioned, up to 10 samples in there. But you can run 5 simultaneously, one at a time. You can have them starting at different times. You could also have them running different targets. So your first one might be looking for Salmonella, the other one might be E. coli, another one for viruses, for example. So it's fantastic, really easy to use, and it only takes 15 minutes to do that entire run. So that's up to 50 samples in 50 minutes if you pulled up to 10. So you could easily do 150 samples or more within just an hour.
Excellent summary. You know, when I talk to people about instrumentation, their questions are how fast is it and how much does it cost, Andy? So what are the costs for a standard run?
The cost is very low, especially when you consider if you're going to pool a sample. So the cost is divided across the 10 samples, and more than makes up for the cost in saving you're going to have by not having to run 10 PCR reactions or 10 ELISA reactions afterwards, for example. So it's very, very cost effective, and that's why most laboratories tend to introduce it, combining that and the efficiency and cleaning of the sample that they're going to get, the enhancement on their performance.
Well, Melanie, thank you so much for your time. I'd like to now allow you to summarize the issue of pathogens in food for testing and the use of the Pathatrix technology as a sample preparation step and automated system and its advantages. And then at the end of that, I'd like to just describe your consultancy at Life Technologies and the types of advantages you feel your organization offers to food testers.
Okay, thank you. So Pathatrix has many benefits, and hopefully you can see that it streamlines your workflow by combining samples, but without affecting the original samples. So that decreases the amount of work that's required, the hands-on time, and the amount of consumables required. It will clean your sample, so it makes your results much more accurate. It will help to reduce the number of false positives you're seeing and false negatives you're seeing. And this system can be used with any detection method, whether it's culture, ELISA, VIDAS, or molecular. And it just sits in between your current workflow, so in between your enrichment and your detection, taking just 15 minutes to run, so it doesn't add a lot of time to your workflow at all. I really enjoyed talking to you about Pathatrix today. It's been great because it does have a lot of advantages for every laboratory, regardless of their skill level and the current methods. But it really is just one of the many solutions that we offer here at Life Technologies for our customers in the food industry. We offer molecular tests, which is perhaps what we're better known for. We have various tests for Salmonella, Listeria, 0157, FTech as well, which is talked about a lot. We also offer custom capabilities as well, so we offer the entire solution for the industry. Our custom capabilities as well really help to differentiate us a lot and make sure that we can meet our customers' needs accurately, but also looking broader than that. The capabilities of Life Technologies as a company, we have several strategic business units, and we all interlink together. So we have systems like the Ion Torrents, where you can sequence your bacteria very, very quickly. Many people are using that now. And we use it internally as well to design our kits, make sure they're as accurate as possible. But we also use it with our custom capabilities. So you may remember a couple of years ago, there was an outbreak of 0104 in Europe, and several people died, including children. And what we did is we worked with the National Reference Laboratory for that, and we were able to sequence the organism which was making people ill, and at that point it was unknown. No one knew what it was. we're able to sequence it, identify it, trace back to source because of that, and then also create a real-time testing kit which was specific to that outbreak strain and could be used by any laboratory. And we did that in just a matter of days, which is unheard of, and it's through the capabilities of the company as a whole. We apply that whole system to many different scenarios. So recently you've probably heard of the horse meat scandal we've had over here in Europe. I think it's crossed the pond now to the US as well. And for all these reasons too, we were used in the London Olympics as well as a testing method. So really what I'd like to say as a summary is that Life Technologies are here as a partner for our customers. We like to provide flexible solutions which suit them now and also moving forward as their requirements change in the future.
Well, Melanie, you've given us an outstanding summary of life sciences interaction in the food safety arena. I'm particularly aware of the Big 6 EHEC subspecies issue and how that really affected not only Europe but also the United States. And we've heard in recent press the horse meat scandal and the speciation mix of beef with horse meat. So many of your topics are familiar to our audience of food production, food quality, food safety, and food security managers. I'd like to thank you for your time today and allow you any closing remarks prior to our close of the interview.
I'd just like to say thank you very much. I appreciate you asking me to join your show and talk about Pathatrix and Life Technologies.
Well, I'd like to thank you and welcome you in the future should you have another topic of interest for our 50,000 listeners to the AME Food Testing Show.
That would be great. Thank you, Andy.
Thank you, and have a great day.
Thank you. Bye.
Bye.